Molten rock at 1200 degrees is advancing toward a town of 4,000 people. One barrier stands between total destruction and survival. In Iceland, engineers are attempting something unprecedented, building walls to stop millions of tons of volcanic lava in real time.
This power plant supplies electricity and hot water to 30,000 people. If the lava reaches it, an entire region goes dark.
Watch as 100 machines work around the clock. This is extreme engineering at the edge of the Earth itself, where humans dare to challenge the raw power of volcanic fire. Before a single load of Earth is moved, engineers run hundreds of lava flow simulations to determine exactly where barriers must rise. Survey teams map every contour of the ancient lava field, identifying the highest ground where barriers will be most effective.
The barriers must protect not just homes, but Grindavík's fishing harbor, one of Iceland's most important ports.
The barriers themselves are built from ancient lava, cooled volcanic rock from the last time these volcanoes erupted 8 centuries ago.
Iron pits are established 2 kilometers from the barrier line, providing millions of cubic meters of volcanic rock and earth.
Temporary roads are carved across the lava field, creating arteries that will carry over 20,000 truckloads of material.
Nearly 100 bulldozers, excavators, and haul trucks are mobilized, the largest earth-moving fleet ever assembled for volcanic defense.
Each barrier follows exact specifications, 40 meters wide at the base, rising to heights of up to 21 meters.
Work begins immediately and never stops. 24 hours a day, 7 days a week, racing against geological time.
560,000 cubic meters of volcanic rock will form the first barrier, enough to fill 20,000 trucks. Foundation layers are spread in 30-centimeter lifts, each pass building structural integrity from the ground up.
Each layer is compacted to 95% density, ensuring the barrier can withstand the immense pressure of advancing lava.
40-ton haulers arrive every 4 to 5 seconds, delivering a continuous stream of volcanic material to the growing barrier.
Traffic coordinators orchestrate a ballet of heavy machinery, directing each 40-ton load to its exact position.
D11 bulldozers with 4-meter blades spread each lift with millimeter precision across the barrier width. GPS-guided graders shape slopes to a precise 2-to-1 ratio, 2 meters horizontal for every meter of height. Specialized compactors work every surface of the barrier, from flat crests to angled slopes, building a solid mass.
GPS surveys verify elevation every 2 meters, ensuring the barrier rises exactly as designed to protect against calculated lava depths.
As the barrier rises, the working platform narrows. Operators navigate spaces just meters wider than their machines. Temporary ramps rise with the barrier itself, allowing 40-ton haulers to deliver material at ever-increasing heights.
Night shifts work under 2 million lumen lighting systems, maintaining the same pace as daylight operations.
The first section reaches 8 meters, tall as a 3-story building, ready to face whatever the volcano sends. Construction advances on multiple fronts, building up while extending outward across the 7-kilometer defensive line.
Strategic alignment on high ground means 8 meters of barrier provides 12 meters of lava resistance.
Critical infrastructure zones receive barriers up to 21 meters high, taller than a 6-story building, built in weeks.
6 primary barrier segments form a protective arc around the power plant, 5.5 kilometers of volcanic defense. With the power plant secured, resources pivot to protect Grindavík, home to 4,000 residents and Iceland's vital fishing fleet.
New material sources are established closer to Grindavík, reducing haul distances and accelerating construction.
The Grindavík barrier will stretch 16 kilometers in a half-circle around the town, twice the length of the power plant defenses.
The fishing harbor drives Grindavík's economy. It receives the first completed section of the town's protective barrier.
3 construction fronts advance simultaneously, encircling the town in an arc of volcanic defense.
Where barrier segments meet, material is interlocked, creating continuous protection without weak joints.
13 kilometers of barriers now defend critical infrastructure, more than 130 football fields of volcanic defense.
January 2024, the barriers face their ultimate test as molten lava advances toward Grindavik at 1200 degrees.
The barrier holds. Lava deflects along the engineered contour, diverted away from homes and infrastructure.
Post-eruption inspection confirms complete success. Lava piled 3 meters high against the barrier without breach.
Real-world testing drives improvements. Critical sections are raised from 8 to 21 meters based on observed lava behavior.
Engineers integrate the 1973 Haimae technique, massive pumps to spray seawater directly onto advancing lava. The cooling system delivers 1,000 liters per second, enough to solidify 12,000 square meters of advancing lava.
16 kilometers of barriers, 38 kilometers of access roads.
Quality control teams verify every 50 meters. Compaction density, elevation accuracy, slope geometry checked and documented.
LiDAR drones capture every centimeter of completed barriers, creating permanent records for future engineering reference.
Maintenance roads along barrier crests enable rapid inspection and emergency response across the entire network. Seismic monitors detect the slightest ground movement. Early warning systems give hours to prepare for approaching lava.
24-hour monitoring tracks every tremor, every ground shift. The barrier network operates as a living defense system.
Response drills ensure crews can mobilize in 15 minutes. Equipment running, pumps pressurized, defenses active.
Maintenance crews work continuously, repairing erosion, reinforcing settlement, ensuring barriers remain at full strength.
Multiple eruptions in 2024 each test the barriers, and each time, the defenses hold.
Scientific analysis confirms barriers held lava 5 meters deep, exceeding design specifications by 40%. Experience drives expansion. New barrier sections address lava pathways revealed by actual eruption behavior.
9 kilometers of roads now cross terrain that was molten rock just months ago, cooled, leveled, and stabilized for vehicle traffic. The same techniques that save towns now rebuild tourist routes. The Blue Lagoon Road rises over lava that covered the original.
Critical infrastructure is buried deeper. Hot water pipes, power cables, communications, protected even if lava overtops barriers.
Power lines are raised and insulated, maintaining electricity to 30,000 people even during active eruptions.
Behind the barriers, normal life continues. Children attend school. Fishermen work their boats.
1973, Jaime Island, the world's first successful lava diversion operation, the foundation for everything built today.
Over 5 months, workers pumped 7.3 million cubic meters of seawater, enough to fill 3,000 Olympic swimming pools.
The harbor survived. The cooled lava became a breakwater, improving the harbor. The town rebuilt. A technique was proven. 50 years of documentation transferred to today's engineers. Every lesson from Haimae applied to the Reykjanes defenses.
From manual firefighting to GPS-guided earth-moving, volcanic defense evolved from desperate improvisation to systematic engineering. 2.5 million cubic meters of earth. A truck convoy that would stretch from Reykjavik to Copenhagen.
Hundreds of workers, equipment operators, engineers, surveyors, the people who dared to stand between a volcano and their communities.
Expert operators like these moved 40 tons with every bucket, precision honed through thousands of hours in the cab.
12-hour night shifts in freezing darkness. Workers arrived, knowing their community's survival depended on never stopping. Wind, rain, volcanic ash, nothing stopped construction. Equipment was modified, workers adapted, but the work continued. 0 serious injuries despite working beside active volcanoes. Rigorous safety protocols protected every worker.
Engineers from Italy, Japan, Hawaii, Indonesia study Iceland's defenses. This project becomes the global template for volcanic protection.
Technical specifications are published worldwide. Iceland's experience becomes permanent engineering knowledge for future volcanic defense.
Scientists predict eruptions will continue for centuries. These barriers are not temporary. They are permanent infrastructure for volcanic coexistence.
The barrier network continues growing. Each eruption teaches lessons that drive continuous improvement.
Drones track lava flows in real time. Thermal imaging identifies priority cooling zones. Technology continues advancing volcanic defense.
Cooling systems now activate within minutes. Pre-positioned pipes ready to spray thousands of liters per second.
Every component, barriers, cooling, monitoring, response, functions as one integrated system, defending thousands of lives.
Property values hold, businesses thrive, residents stay. The barriers transformed existential threat into manageable risk.
Protected assets exceed $500 million. Barrier costs were a fraction of what they save every year.
Humans cannot stop volcanoes, but they can build walls of earth and determination that bend fire away from what matters most.
Hawaii bombed lava flows. Italy built concrete walls. Japan constructed debris dams. Iceland's planning never stops. Engineers prepare for decades of potential volcanic activity, with expansion proposals already in development. Winter maintenance ensures barriers remain at full strength. Frost damage inspected, settlement corrected, access roads cleared.
Response times improved 40% through continuous training. Crews now mobilize in under 12 minutes from alert.
Engineers from 12 volcanic nations gather in Reykjavik to learn Iceland's techniques, knowledge shared freely with the world.
4 key innovations documented for global use: GPS guidance, flow modeling, multi-front construction, and rapid cooling deployment.
The government honors the workers who built the barriers, equipment operators, engineers, and support staff who protected their nation.
Grindavik celebrates survival. Families gather where fear once dominated, the barriers making joy possible again.
Independent auditors certify the barrier network meets all specifications. Official recognition of protective infrastructure status.
Permanent signage marks the barrier network, identification in Icelandic and English for residents and visitors alike. Public viewing areas allow visitors to safely witness the barriers, engineering achievement accessible to all.
Educational programs bring students to the barriers, teaching engineering, geology, and community resilience through direct experience.
Thousands of hours of footage document every phase. Visual archives preserve the construction story for future generations.
Original documents and digital records enter the National Archives. Permanent preservation of Iceland's volcanic defense achievement. Monitoring continues 24 hours a day, every day. Permanent vigilance protecting permanent infrastructure.
Annual reviews assess performance, identify improvements, and ensure the barrier network evolves with experience.
Equipment maintenance ensures machines remain ready. The fleet that built the barriers stands prepared for any future need. Training programs ensure expertise continues. New operators learning from veterans who built the original barriers.
6 months of construction, 100 machines, thousands of workers, 2.5 million cubic meters. Watch it rise. From raw volcanic rock to 16 kilometers of protection, a transformation that took 6 months, built by hundreds of hands.
Final inspections confirm every meter meets specification. Technical excellence achieved across 16 kilometers of volcanic defense.
6 months, 2.5 million cubic meters.
16 kilometers of protection, 30,000 lives secured, a town's future preserved.
Behind these walls of earth and determination, life goes on. Children attend school.
Subscribe to Industrial Evolution for more videos exploring how the modern world is built.